Welcome back. This is tutorial 3 on learning to use Geogebra. So in this tutorial what we want to do is extend a little bit on the concepts that we talked about last time, get a little more practice with constructing the geometric figures, introduce a couple of new ideas. So what we want to do here is create an isosceles triangle. And so the isosceles triangle, unlike the equilateral triangle, has only two sides of the triangle that are equal. And then the corresponding opposite angles to those sides will also be equal. So I've already got us into the geometric perspective. I've got to options and labeled new points only. So let's get started. So we want to get started very similar to what we did when creating the equilateral triangle. We want to create a line segment, and it doesn't really matter how that line segment is located. Just create points A and B, and that'll create the base of our triangle. So this time the base is going to be an arbitrary length, and the corresponding other two sides are going to have to be equal, but not necessarily equal to the base. So how are we going to do that? So what we need to do is we need to go to point, and we need to create a point at the midpoint of segment AB, or at the midpoint of the base of our triangle. So go to the midpoint under the points tool bar, and then just select our line segment. And what that will do is create a point right in the middle between A and B. So now what we're going to do is we're going to create a perpendicular line to AB that goes through C. Okay, and now we want to create the point that's going to define the tip of our triangle. And so that can be an arbitrary point. Doesn't matter at this point where it's located. It just needs to be located on that perpendicular line that we just created. So go ahead and place that point. It'll be called D. So now if you notice, what do we have? So if we connect line segments from A to D and from B to D, what we have is those two line segments will actually be equal in length. Why is that? Well, the distance from C to B is equal to the distance from C to A. That's by definition. We place that point C at the midpoint between A and B, and they both share a common length, CD, for one of their sides. So by the side theorem of elementary geometry, we know that sides AD and sides BD have to be equal because their other two sides are equal. So all we need to do is just create line segments from points A to D and from point B to D. And there we go. So we have our sides of our equilateral triangle defined. So now all we need to do now is go and create the polygon. So again, going in a counterclockwise direction, click on points A, points B, point D, and back to point A. We don't need to include point C in that. Okay, so that actually creates our isosceles triangle. So let's go ahead now and get rid of our perpendicular bisector line. And let's also get rid of the visibility for point C. And that'll just leave us with our triangle. So let's go ahead and do the drag test, move it around. Things look pretty good. We can move point B around however we want. We can move A around as well. And we can move D up and down. You can't move it laterally because it's on that perpendicular bisector line, but you can move it up and down. So now let's go and do what we did last time and show the angles. So click on the angle toolbar, click in the center of the triangle, and that will show our angle. So in this case, all three of the angles are not going to be equal, but the angles corresponding to the opposite of the sides that are equal are going to be equal, and this angle that's opposite of the base does not have to be equal to those two. But as you know, they will all three sum up to be 180 degrees, which will show, actually create a tutorial later in Geogebra where we can actually show that visually. So that's what we have. I'll go ahead and take out the labels and just show the values like we did last time. Clean it up just a little bit. And now we'll go ahead and go one step further, is we'll show the values of the lengths of these sides as well. So these two sides should have equal length if we did things correctly. That won't necessarily be equal to the base. So let's double click on each of the sides, go to Object Properties, and click on Show Label, and click on Value. And that'll show the length of that side relative to our coordinate system. Do that for all three of the sides. And so now we can see very clearly that the length of these two sides are equal and not necessarily equal to the length of the base. So we do indeed have an isosceles triangle. The angles opposite to our equal sides are also equal and are different from the angle that's opposite the angle of the base. But the nice part about GeoGebra, which is why this is a nice example, is as you go around and change the values of the move the points around for point B, change the length of the sides, you can see that GeoGebra will dynamically update the lengths of the sides and the angles. So in the case where just moving around point B, it just changes the length of the sides, but it doesn't change the angles. Similarly, if I move around point A, but if we go up here to point D and we move that up and down, now we can see that we can change the angles and we can change those two sides, but our two sides are always remaining equal to each other. These two angles are always remaining equal to each other. But you can just kind of go around and play with the figure and see what happens, with the dynamic updates as you kind of change the value of all of the properties of your triangle. So that's a very neat thing that you can do to play around with these figures once you've created them and to see how the properties of those figures change, in a very intuitive way. So that's it for this tutorial. Play around with this and have some fun, and I'll see you next time.